Okay, let's take a look at this problem. Try to draw the picture first. Okay, this is a square, so this could be x, this can be x. Of course, all the sides are x. This is our length, so that'll be our y. And it's wanting us to this is where I saw it just a minute ago. Largest package. So they want us to maximize the volume. Now our volume is going to equal to our width times our height times our length. So the sides multiply together. So we got x times y. So that's going to be x squared y. And it says the septic package, if its length plus its girth is not more than 102 inches. So length, which is y, plus the girth. And they say the girth from this picture is all the way around. So if this side's x, this side's x, x plus x plus x plus x is 4x. And going to equal to 102. I said it equal to 102 because it can't be greater than 102. So 102 is our maximum we can work with. So this is our constraint. Step 1. Take the constraint equation, get 0 on one side. So I'll take the 102 over. So we've got y plus 4x minus 102 equals 0. This is our g of xy. Step 2. Create a new function. F of xy lambda equals the original function. So f of xy lambda is equal to the original function, which was x squared y. Is it minus plus lambda times g of xy. So plus lambda times the function we found right here. So y plus 4x minus 102. This is step 1. This is step 2. Step 3, you want to find some partials with respect to x, y, and lambda. And I better simplify that first. Okay, let's try that again. This is x squared y plus lambda times y is lambda y. Lambda times 4x is 4x lambda. And lambda times negative 102 is negative 102 lambda. Okay. Then we want to find the partial with respect to x. So I'll treat the y and lambda as constants. Y is a constant. So derivative of x squared is 2x. And then I'll throw the y on. This does not have an x, so the entire thing is a constant. The derivative of a constant is 0. Here we got 4x lambda. So x is our variable we're working with, so this will be 4 lambda. And that goes to 0. The partial with respect to y. X squared would be a constant, so the derivative of y is 1. 1 times x squared is x squared. The lambda is our constant, so the same as if you had 5y, the derivative of 5y is 5, the derivative of lambda y is lambda. And here would be 4x. Wait a minute. Try that again. Okay, we're taking a partial with respect to y. There is no y here, so that goes to 0. There's no y here, so that goes to 0. And interestingly enough, the partial with respect to y, lambda, is always equal to our original constraint. So y plus 4x minus 102. Okay. Step 4. I set partial respect to x, partial respect to y equal to 0 and solve them. So I got 2xy plus 4 lambda equal to 0. And here I'm going to have x squared plus lambda equal to 0. And then I say, let's try it again, x squared plus lambda equal to 0. I then say solve each of the partials for lambda. So here, take the 2xy over, becomes a negative 2xy. Divide both sides by 4, and you get lambda is equal to negative 2/4 or negative 1/2 xy. And here, take the x squared over, becomes a negative x squared. Then set these equal to each other and solve for y. Is that still in the same step? Yeah, step 4. Long step. So I'm going to have negative 1/2 xy equals negative x squared. I can multiply both sides by negative 1. And we get 1/2 xy equals x squared. Multiply both sides by 2. And we get xy is equal to 2x squared. Divide both sides by x. And you get y is equal to 2x squared over x, which gives us 2x. Now this is assumption that x cannot equal to 0. Can't do that otherwise. But then I started thinking x cannot be equal to 0 based upon the problem definition, because then there would be no volume. Okay, so y is equal to 2x. What's it tell us now? Plug this into our partial respect to y and solve. What was our partial respect to y? Y plug this into the partial respect to lambda and solve. Okay. Y plus 4x minus 102 equal to 0. And down here we just said y is equal to 2x. So we're going to have 2x plus 4x minus 102 equals 0. 6x, take the negative 102 over, it becomes a positive 102. Divide both sides by 6. And, 17. Now we then plug that in to find our y. So y is going to equal to 2 times x, 2 times 17, which gives us 34. Let's see. This is our critical point. Now I say plug this into your objective function. Largest is your max, smallest is your min. But obviously we can't have a min. The min would be 0. X equals 0, and then what would y be? I'd have to put 0 in for x here. Y would be 102. That's interesting. But anyway, it doesn't make any sense for a min, so that's our max. Let's see what the problem's asking for, though. Okay, so we got 17, 17, 34. Now for the volume. If you're wondering how they get that, I'm not going to finish this problem. But you come up here, and here's our formula for volume. So you plug in your x and your y, and that'll give you your answer.